Oh, I'm sorry. My apologies. I was just meditating on the dividend discount models here. I might turn that thing off. Okay. Anyway, let's continue, dear. I know. Doesn't it sound like something incredibly uh, uh, foreign? Some mystical? No, it's just the words. The words are dumb. They're not something you're used to using. But the calculations are really very easy, dear students. Very easy. Do them a few times on your 99-cent calculator, and then we'll show you how to use the spreadsheets, which make life a lot easier. So let's continue now on slide number 21. The discounted cash flow model. This is my favorite model, folks. I'll tell you my biases right up front. This is a powerful version of the dividend discount model. It is calculated by taking the present value of all expected future cash flows. Huh? And there's something that looks like math. Oh no, look, relax. I told you all you needed was a 99-cent calculator, and I'm going to make good on that. The value is equal to the cash flow in the year number one. That's what that little one means. And if you're looking at this on your phone, you're probably having a hard time seeing it. Divided by 1 plus the discount rate. Remember the required rate of return, the expected rate of return, the desired rate of return, the discount rate. And then you add to that the cash flow in year number 2 divided by 1 plus the rate squared. Oh no, exponentiation. Relax, you don't have to do it. You can if you want, if you like exponents. And then in year number 3, you take the cash flow in year number 3 and divide that by 1 plus the rate to the 3rd power, and then the 4th year and the 5th year on in perpetuity. So relaxing you are, because you don't have to do you don't have to do any exponentiation, no squaring, no 3rd power. Let's take a look at an example. Let's say we're looking at a company that we believe or we know they're going to give us 3 annual dividends of $10 per share, and then 0 dividends from then on. Required rate of return is, let's say, 7%. To calculate this using exponentiation, we would take the $10 cash flow in the year number 1 divided by 1 plus the rate, 1.07. Make sure you understand that. 1 plus 7% is 1.07. Plus $10 divided by 1.07 squared, plus $10 divided by 1.07 to the 3rd power, because we're going to get $10 in 3 installments each year. And if you do that calculation, you get $26.24. Now, you're going to get $30, right, over the 3 years. But if you remember, maybe you did the time value of money calculations back in chapter 1. Maybe you didn't, it wasn't important. But realize that $30 over the next 3 years is not equal to $30 today. Okay, so that $30 we're going to get over the next 3 years if we want a 7% rate of return. You change the rate of return, you change the discount rate, all the numbers change. Is worth to us, that $30 over the next 3 years is worth to us today $26.24. But how often do companies pay 3 annual dividends and then promptly go out of business? Plus, Piano, we keep using this term present value. What does the present value mean anyway? That's one of the problems with this teaching this, is getting the words out of the way because they just don't sound right. So, what is present value? The present value is the value today of a lump sum or series of payments to be received at some future date. It's the other side of the coin. It's the opposite, the inverse operation of future value. Did you work on the future value calculations back in chapter 1? You didn't have to. I told you didn't have to. I hope you just looked at the amounts that can be earned over long periods of time, because it's very substantial. The future value of $10,000 in 10 years at 10% is equal to $10,000 times the future value multiplier of 2.594. And there's the formula, 1 plus 10% to the 10 years. So if we were to put 10% into an investment that's earning $10,000 into an investment that's earning 10%, in 10 years, we'd have $25,940. Now, if we knew, or we believed we're going to get $25,940 in 10 years, and we require a 10% rate of return, what is that $25,940 worth to us that we're going to get in 10 years? What is it worth to us today? Well, we use the present value multiplier, which we're going to take a look at in just a moment, at 10% for 10 years. And there's the formula. You don't have to do it. And it turns out that that $25,940 that we believe we're going to get in 10 years today is worth to us $10,000. Present value and future value are just two sides of the same coin. In finance, present value tells us what the future value is worth today, an amount we're going to get sometime in the future. What is it worth to us today? Those 3 payments of $30 today at 7% are worth a little over 26 bucks. Computing the present value is called discounting. I know, I know it sounds kind of dumb, but get used to it because that's the term you're going to hear in the industry. And you, after today, are going to be an investment guru. So you have to understand that discounting is taking some future value that you're going to get in the future and bringing it back to the present. Sorry. I wish I could come up with a better verb and name, but I don't have one. And this is what you have to learn because you're going to be the investment guru. So, slide number 23. Did the formula for the model scare you? Cash flow from year number 1 divided by 1 plus rate plus to the first power. We don't have to put it there. Plus cash flow for year number 2 divided by 1 plus rate to the second power, plus cash flow year number 3 times 1 divided by 1 plus rate to the third power. The formula has the present value built into it. We mortals simply use the present value tables to discount the future annual cash flows, just optionally as we used the future value tables in chapter 1. So the formula becomes the cash flow for year number 1 times PVM, present value multiplier for year number 1, plus the cash flow for year number 2 times the present value multiplier for year number 2, plus the cash flow for year number 3 times the present value multiplier for year number 3, and on and on and on as far into the future as you want. But 3, 4, 5 years is about all we can possibly ever predict. Okay, with me? I hope so. Because now we're going to take a look at the present value table. Let's do the same example over again using the present value multipliers from the present value table. There's the link, and I have it queued up on the website here. There are the formulas. You want to print those out to have them in your hot little hand. And on the other side of the page, we put the present value table because that's very important. Here's the present value table. And so it doesn't fit on the page, on my apologies, but we said 7%, right? Can I move it? Can I move it? I can't. It's not going to let me move it. But over here is year number 1, 2, 3. Over, you can't see it, but can I sneak it around? Oh, I'll just make it smaller, and you'll have a hard time seeing it. Let's try 65%. Let's try 63% or 62%. Now you can see it. Now probably you can't because you're looking on your phone. You can't see it. But here's year 1, 2, 3, 4, 5. About as far as we could go is 1, 2, 3, 4, 5. And we go over to 7% because remember we were looking for 7% for 3 years, $10 for 3 years. So we're going to get $10 in year number 1, $10 in year number 2, and $10 in year number 3. So we go down to year number 3 and across to 7%, or you can go across 7% down to year number 3. Actually, before that, we got year number 1 first. 7% is 0.935 for year number 1. For year number 2, it's 0.873. For year number 3, it's 0.816. You see that? Those first 3 present value multipliers. And that's what we use. 0.935, 0.873, 0.816. I got my mouse is so, I have to get a different mouse. This is so darn sensitive. So $9.35, $10 times 0.935. $10 times 0.873, $8.73. $10 times 0.816. So that $10 that we're going to get a year from now at 7% today is worth $9.35. That $10 we're going to get 2 years from now is worth $8.73. That $10 we're going to get in 3 years at 7% is worth $8.16. You add them together and you get $26.24. So is it starting to percolate? What is the present value of the future stream of dividends? The dividends are $10, $10, and $10. At 7%, that $10 in 1 year is worth $9.35. At 7% in 2 years, that $10 is worth $8.73. And in 3 years, that $10 is worth $8.16. The sum of the present values of the future annual dividend cash flows equals our perceived value of the stock. You see, the value is equal to the present value of the future stream of income. In this case, the income is coming from dividends. So let's take a look at the next slide. And here I'm trying to show you in the slides what we just did. There's the present value table printed out. I think it's a good idea to have it printed out, but it's up to you. We used years 1, 2, and 3, and I cut off, 1 through 4. Year 7, 0.935. Year 1 at 7% is 0.935. Year 2 at 7% is 0.873. Year 3 at 7% is 0.816. We multiplied the cash flow from the dividends in year 1 by the present value multiplier at 7% for year number 1. We did the same for the dividend payments for years 2 and 3. Adding them all together gives us the present value of the future stream of dividend payments. So I hope you will agree, even if the words are still tripping you up, that the calculation is very easy. You just look it up on the table, put it in the formula, and then multiply times the dividends, the amount, the cash flows we're going to get in each year. Our example, though, did not take into account that the stock will still have some worth at the end of the 3 years. To make the model more useful, we simply add our predicted market price of the stock at the end of the 3 years. We treat the price of the stock at the end of the 3 years as a future cash flow. So now the model looks more like this. Value of stock is equal to the present value of the future dividends plus the present value of the price of the stock when we plan to sell. Again, we use the present value multipliers, and again, as with the other dividend discount models, the model is very sensitive to our estimates and our choice of required rate of return. And hence, right, the results are going to vary wildly. But as we said at the beginning, it ain't going to be easy, right? And so you could torture it to make it do whatever you want it to do, but we have to use judgment to decide what are our estimates. So here's that same example, but now let's say, hey, that stock that we were going to get $10 a year for the next 3 years, it's selling for $125. So let's say the current price of the stock is $125. We think in 3 years the stock's going to be worth $135. Okay, maybe, yeah. So we don't know that. We're just predicting. We're putting our finger up in the air and seeing which way the wind blows. So now we create, I like this table form. I think table form makes life a lot easier. We create the cash flows for year number 1, a dividend for year number 1, a dividend for year number 2, and then in year number 3, we're going to get the dividend, plus we're going to think of the stock price in the year number 3 as a future cash flow. So we could sell that stock at $135 at the end of 3 years. So notice that the present value multiplier is the same for year number 1 and the year number 2 as before, but now in year number 3, we use the same present value multiplier. Some people make the mistake of going to year number 4. No. We're getting the dividend in year number 3, and we're assuming we're going to sell the stock at the end of year number 3. So we use the same present value multiplier. Don't get tripped up over that. It's a very easy thing to mess up. So our discounted cash flows are that same $9.35, $8.73, and $8.16. But that $135 stock price today, using the present value multiplier, is only worth $110.16. You see, $135 3 years from now at 7% is worth $110.16 today. That's the present value of that future cash flow. So you add those up, and the model is saying the stock is worth $136.40. So our model says the present value of the future stream of cash flows from this stock is $136.40. The current market price is $125. So the model is telling us, the model is pointing us towards this company. It doesn't mean we jump up and down, scream and holler, and go out and buy it. No. The model is telling us this is a potentially good investment for us at 7%. And let's read again. I know you can't even see it if you're looking at this on your phone, but notice that the present value multiplier for the dividend in year number 3 and the expected stock price at the end of year number 3 are the same. We are receiving the future cash flows in the same year number 3, dividend in year number 3, and the stock price. So we use the same present value multiplier. Okay, so don't let that one trip you up. Cool? Is this cool? I think if you do it enough times, worksheet number 1, worksheet number 2, the assignments, the exam, we're going to do this over and over again. In fact, we're going to do this for the rest of the semester. And so you might as well learn it now, because if you can't leave Business 123 Introduction to Investments without knowing how to do the discounted cash flow model, it's bad for my self-esteem. Okay, slide 28. Here's an example. Pretzels Unlimited, symbol is PU. Pretzels Unlimited is currently selling for $22 a share and will pay $2 per share in dividends in 2024. PU expects to increase their dividends to $2.20 in 2025, $2.30 in 2026, and $2.30 in 2027. We will be selling the stock at the end of 2027, and we expect the price to be $27 per share at that time. Our required rate of return is 12%. So let's take a look at the model again. The present value of the future dividends plus the present value of the price of the stock when we don't have to, but we plan to sell in 4 years, is equal to the value of the stock. So if we go to the present value tables for 12%, and let's go over to 12%. There's 12%. Let's make it a little bit bigger. Now you know that these are the years, right? Years 1, 2, 3, 4. So let's make it a little bit bigger so we can see those numbers a little bit bigger. 0.893, 0.797, 0.712, 0.636. Make sure I got them right, because let's see if I got them right. Yeah, up. My apologies. 0.893. 0.797, 0.712, 0.636. And then notice we do it again, 0.636. Why? Because these are the dividends in years 1, 2, 3, and 4. And at the end of the year 4, we're going to say, okay, let's say the stock is $27. We're going to use that same present value multiplier. I know it's a little tricky. Just do it enough times, and it'll be child's play once you've done it a few times. In fact, you'll be tired of doing it over and over again. You'll be seeing it in your sleep, and then my job is done, and then I'll teach you how to use the spreadsheet so you don't have to do it over and over and over again. So that's $1.786, $1.7534, $1.6376 plus $1.4628. Those are the dividends. And then the $27 times 0.636 is equal to a little over $17. You add all those things up and you get $23.81. So the stock is selling for $22. The model is saying we think it's worth $23.81 if our required rate of return of 12%. If you changed it to 14% or 10%, you see what you got to do? You got to go through and do all those calculations again. And that's why the spreadsheet does it for us. But just hang on, do it enough times manually, and then the spreadsheet will be your friend. With a market price of $22, this is a potentially good investment. Does it mean we run out and buy Pretzels Unlimited? No, 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 no. You get 5 no's. No, it means we do more research. The model is pointing us towards companies like that. Make sense? Okay, now let's continue because it's going to get really exciting in my humble opinion. I love this spreadsheet format. I think it makes it easier to understand. You put the years on the left-hand side and then the cash flows and then the present value multipliers, and you do the calculations. Notice that the present value multiplier for the dividend and the expected price of the stock in year number 4 are the same because we're receiving these cash flows in year number 4, 2027. You add them all up and you get $23.81. Here is the problem in spreadsheet format. I think it is much easier to comprehend and calculate in this format. Yes, but let's simplify it a bit. Let's add the dividend in year number 4, 2027, to the stock price that we expect to see in 4 years or so, and then do the calculation. First of all, it removes some manual calculations, and so it's a little easier to understand, I think. But more importantly, it allows us to use a special spreadsheet function. But before we do that, let's take a look at it again. Make sure we understand. In year number 1, 2024, we're going to get $2. We multiply that times the present value multiplier of 0.893 for 12% for year number 1 using the table. Let's run over it to make sure we got it. Yeah, 0.893, 0.979, 0.712, 0.636 for the first 4 years. So that's worth a little over $1.78, right? In year number 2, 2025, $2.20 times 0.979 is $1.7534. Yes. And year number 3, $2.30 times 0.712, $1.63 is $9.79. You don't have to worry about using all the digits, but I do. We're not trying to get precise here. And then in year number 4, what did we do? In 2027, we added the dividend of $2.30 to the expected future price, and that's $29.30, multiplied times the present value multiplier. Is that right? 636? Yeah, 636, right? I'm sorry, I was all of a sudden doubting myself here. 18.6348, and that gives us $23.81. But again, adding it, you notice we had fewer calculations to do manually, but more importantly, it allows us to use a special spreadsheet function to calculate the internal rate of return. IRR. The internal rate of return is a measure of what rate of return we expect to get from this series of cash flows, including both positive and negative flows. We were just doing positive flows. And internal rate of return is very important once you enter the upper division, graduate level classes. They're going to be jumping up and down, screaming and hollering that you have to understand internal rate of return upside down, at left side, right. And someday when you take that upper level or graduate finance or investment class, you will learn how to manually compute internal rate of return. Hopefully, you will not have a sadistic professor who will require you to do it more than once. It's not that it's that hard. It's just a whole lot of calculations, really, really tedious calculations. And then if you don't get the right answer, because it's kind of a guessing game, then you got to do it all over again. That's why we have computers. The computer can do it for us. Lickety split. We're going to simply, we are simply going to enter the numbers into a spreadsheet formula and then press the enter key, okay? Okay, so we're going to teach you how to do internal rate of return using the spreadsheet. If you really are that excited that you want to learn how to do it manually, contact me and we'll schedule a session to show you how to do it. It's not hard. It's just really, really tedious. And that's why we have computers. Okay, in other words, we asked for, we desired, we gave our discount rate as 12% rate of return from Pretzels Unlimited. But what do the numbers tell us will be our expected rate of return? In other words, if we do indeed get these cash flows that we're thinking we're going to get, we're predicting, we know we're not going to get them. We pretty much positively know we're not going to get them. But that's what our judgment believes we're going to get. What is the rate of return? And that's what internal rate of return will tell you. The spreadsheet formula, and if you haven't used the spreadsheet, I hope you start playing with it. It's like a big bingo game. It's a bingo calculator. They're not hard to use. They're so sophisticated now that there are not millions, but thousands of things it can do that most people just use about 4 or 5. Here's the spreadsheet formula. Equal sign, and that means it's a formula. IRR for internal rate of return. The block of cells that contains the values, both positive and negative. Any money coming out the door, going out the door, and money coming in the door, that's a positive. And then you choose what you think the return is going to be. Actually, you can leave it 0 and let the computer try to figure it out. But if you give it an approximate rate of return you think it's going to be, it'll help the computer's algorithm, the process. So in this case, the cash outflow, because internal rate of return needs the negative outflows. How much does it cost you for this investment? So we start from year 0, time 0 right now, and we pay $22. Our initial outlay is $22. So we enter all outflows as negative numbers. Remember, the parentheses means it's negative, and ask your accounting instructor why. It's a long story. 2024, we're going to get $2. 2025, we're going to get $2.20. 2026, $2.30. And then in 2027, we add the $2.30 dividend plus the $27 that we believe the stock is going to be worth in 4 years. And then we do the calculation. In this case, IRR, this is column A, column B, column C. This is row 1, 2, 3, 4, 5, 6. So we go from B2, like bingo, right, down to B6, 2, 3, 4, 5, 6. And then we put 12% in. We could have left it at 0 and let the computer try to figure it out. But we say, well, we think it's about 12%. And what does the computer come back? Oh, the computer comes back and says, if you indeed pay $22 for this stock and get these 4 dividends and the stock is worth $27, you're going to actually get a 14.51% return. Now, sometimes internal rate of return will come back and say, oops, I can't do it. And then you got to play with the numbers a little bit. And it might be that it can't do it. If you left this blank, if you said, I'm going to get $2.20, and I'm not going to have to pay anything for it, internal rate of return was going to say you get an infinite return because you're not paying anything for what you're getting. So somebody's giving you that money. So that doesn't work then. You see, it's some instances where it doesn't work, but you'll figure it out once you start putting in silly numbers and it comes back and says, I don't know what you're doing to me. But it's just, now, how many investors do you think know how to do this? You are one of them. You are one of the official investment gurus that can create a present value of a future stream of income and then put it into a spreadsheet. And I'm going to show you how to do it. Don't worry, play with the spreadsheet. And create a internal rate of return and say, this is, well, though, these numbers, we're just putting those in. We don't know that we're going to get them. We know we probably won't get them, but we might. And that's where judgment comes in. And that's where we look at the company. Now, how exciting is a pretzel company? Not too exciting, right? So if they've been raising their dividend the way we've seen them raise their dividend, they're probably going to continue doing so unless there's something happens. And we've seen the stock price do this, and we're going to see some other tools to help us figure it out. I think this is really exciting. Now, what we're going to do now, actually, wait a minute, do I have a present? I do have that, don't I? Wait, let's go back here. And yeah, I do have a, oh no, I don't. I'm going to put a presentation on how to use Pretzel's Unlimited Discounted Cash Flow spreadsheet. Okay, well, actually, why don't we just take a look at it now? Let's take a look at the spreadsheet now. Why do I have to create? Because I know why. Because this, I'm gonna have to do it. I'm gonna do it because it messes up with the presentation file. So I'm gonna create a. So look for a little presentation here that shows you how to use Pretzels Unlimited. This is what we would do in the face-to-face class, of course. Okay. So now let's continue. Let's continue because now we're going to take a look at an example. Oh boy, this is so much fun. Where the company doesn't pay any dividends. Whoa, is that exciting? Yes. Here is a company called Jeans or Us. Yeah. Did you hear what the one chromosome said to the other chromosome? Do these jeans make me look fat? See what you're missing in the face-to-face class? Jeans or Us is currently selling for $21 per share. It pays no dividends. We believe that Jeans or Us will sell around $50 in 5 years. Our required rate of return is 13%. How can we determine if this is a potentially good investment? Well, with no dividends, we can't use the zero growth model. We can't use the dividend discount. We can't use the Gordon growth model. But with no dividends, we can still use the discounted cash flow model. Why? Because the model is the value of the stock is equal to the present value of the future dividends plus the present value of the price of the stock when we plan to sell. Well, if we're not getting any dividends, what's the present value of future dividends? Yeah, present value of 0 is 0. so we just ignore that part of the formula. Just throw it away. But we expect the price to be $50 in 5 years. And at 13%, what's that future value multiplier? Let's go back to the present value table. And at 5 years, let's make it a little bit bigger. How about 60%? Oops, that was too big, too fast. So here's 5 years. There's 5 years. At 13%, it's 0.543. Can you see it? Maybe not. Print out the present value table and make sure you have it. You go across the 13% down 5 years, and that's 0.543. So we multiply $50 times 0.543. And that's equal to $27.15. So we say to ourselves, the stock is selling for $21. But the model is telling us if we get $50 in 5 years at 13%, it's worth $27. Now, can you see the difference between a Jeans or Us, a company that may be based here in San Diego, biotech company that's working on the next drug that may cure baldness or whatever, or might turn out that it's a abject failure and it turns your liver into pate and it makes your eyes turn inside out. Difference between that company and the difference between a company that's been selling pretzels for 80 years. Yeah, the pretzel company is boring and a food company, yeah. Whereas the Jeans or Us company is real speculative, hot stock, hot issue. It might be $50 in 5 years. It might be $500 in 5 years. It probably will be 50 cents in 5 years. You see now how not all stocks are the same. And this model, even if the model looks really cute and it tells us that, yeah, this is really going to be worth something, but we have to remember that we're just, blowing smoke here. We're just putting our finger up in the air and seeing which way the wind blows. And with some companies, we can do a whole lot better job of that than with other companies. Now, am I saying you should never, ever buy a Jeans or Us? No, not at all. But for every one Jeans or Us, how about buying 4 or 5 Pretzels Unlimited? Kellogg's, and maybe ExxonMobil, and maybe Nike, companies that have been around for decades, roots deep in the economy. And you're not going to get rich overnight, but you're also not going to get poor overnight. And if you don't believe me, go look at the symbol for GoPro. Is it GPRO? Yes, I remember. I call it go broke. They're not alone. Companies that have meteoric rises and then meteoric falls. Okay, so let's continue. Let's apply the two spreadsheets that we talked about to Jeans or Us. The current market price is $21 and we expect the stock price to be $50 in 5 years. Again, Jeans or Us pays no dividends. So notice we can construct this spreadsheet. We don't have to. We only have to do is the last calculation. But in 2024, 0. 2025, 0. 2026, 0. 2027, 0. But in 2028, if the stock does hit $50, we can turn around and sell it, and that's a cash flow. So you multiply it times the present value multiplier, 0.543, and it gives us $27.15. If we use the internal rate of return calculation, we need to put in the initial cash flow of negative $21, because that's what it's priced. That's the prices. We have to pay $21 to get the stock. And then we have to put these in. You can't leave them out. You have to put in 2024, 2025, 2026, 2027, even though we're not getting any income. You still have to put those years in, or internal rate of return won't work. And then you put, for 2028, $50, the expected stock price, and internal rate of return from B2 to B7. Notice I put 0 there. I said, you figure it out, internal rate spreadsheet, you figure it out. And of course, Excel has it, and so does Google Docs and LibreOffice. So the internal rate of return calculation comes back and says, look, if you pay $21 now and you get $50 in 5 years, you're going to get almost 19%, 18.95%. Pretty darn good. But you see how speculative and how dangerous a company like this is? And I'm not saying you should never invest in them. Never worked out for me. They all went up, but then they all went down. You can't leave BUS123 without knowing how to compute the Gordon growth model and the discounted cash flow model. It's bad for my self-esteem. And they're going to be on exam number 2, and exam number 3, and exam number 4, and I'm pounding on the desk. And the final exam, so please learn them now. Study the spreadsheets. Contact me for help. I'm here to help you. Dear students, I can talk about this far longer than any reasonable person would ever want to listen. Because I live in, this is my favorite model, folks. This is what I do for fun. I go to the library with the value line. I'm getting ahead of myself. With my wife, because she's into historical novels. And I play with this model. On my laptop, I got my laptop. I'm going to show you how to use the spreadsheets. Very, very simple. Once you know what you're doing with them. Once you've done these calculations a few times, they're very simple. It's the words that get in the way. So slide number 35. I warned you that these are just a few of the many different models out there. There's the residual income model, which is kind of like the Gordon growth model, but it uses earnings instead of dividends. So companies that don't pay dividends, we can look at their earnings. The free cash flow model, which is kind of like the residual income model, but it takes into account non-cash expense items. What? Chapter 5. Okay, the price ratio models that use various price ratios and estimated growth rates to predict the future price of the stock. There are dozens of these things out there. You have the rest of your investing career to explore them. Please contact me when you find one that is better than the discounted cash flow model for dividend-producing companies, okay? And we're also going to take a look at the stock selection guide from Better Investing. I think I already said this, which is a very cool model that's been around, again, since the 1950s. So some of these models are tried and true. Are they guarantees? You know what I'm going to say, right? No. And we need judgment. We need experience. We need to make a few mistakes. We're going to do some things really well. We're going to make a few mistakes. Yeah. Think about it, folks. If you can hit a fastball at 98 miles an hour 3 times out of 10, you're going to make millions of dollars. And you're going to do a whole lot better than 3 out of 10. Trust me. If you follow the concepts that we learn here, you're not going to get rich overnight, but you're going to build wealth. I think so. It's worked for me so far, and I'm old. Okay, Payano. This is all great. But just where are we supposed to get all this historical information anyway? And just who decides what next year's earnings or dividends per share, the dividend growth rate, etc. are going to be, let alone the expected price of the stock in 3 to 5 years? It's a good question. Before the internet, this information was not readily available. Normally, you would go and ask your broker for it. You create a relationship with your broker. Now, the internet has made everything available. Or you would use one of the trusted information sources available in the securities industry. And traditionally, for over 90 years, the most respected source, and still the best, in my humble opinion, was the value line. I think I made mention of the value line accidentally. Yeah, folks. So we're going to show you. You now are official investment gurus. We're going to show you how to use the value line. And it's not the only one out there, folks. It's not the only one out there to use these, to get the data, to plug into these models and start your investing career. So when we come back, we will continue and discuss the value line and see a spreadsheet that does pretty much all the work for us. Is this cool or what? You are now official investment gurus. No longer are you rising. You have come and seen the mountaintop and have looked down upon the valley in front of you, and you have a whole lifetime to play with these things and learn about others. And I'm so proud of you. I am so, so honored and privileged to have shown you the path. See you in our last presentation for Chapter 4 when we dig into the value line, a sip from the financial fire hose.